Now that we've seen some of the fundamental concepts of relational databases that we're going to be learning about in detail in this course, let's look at an example of a database from a healthcare management domain to see how these concepts play out in practice intuitively. For a healthcare management application, we'd like to talk about several different functions. For example, appointment scheduling and management. For patients to make appointments, to be able to manage, change appointments, and so forth. Managing patient records, of course, their medical records, their address and phone numbers, contact information, and so forth. And to also manage with the schedules of the doctors and their availability. And this means that we need to be storing, at a minimum, three kinds of information. We need information about patients. We need information about the different doctors in the system. And also we need scheduling information, which is, in fact, what connects the patients with the doctors. Patients make appointments with particular doctors at particular times and so forth. So let's jump in here and look at patient data. So for patient data, we would have some kind of a database table representing information about the patients. Each patient has a unique patient ID, their name, first name, last name, their date of birth, some other information about them, their phone number, address, whatever other information we have about the patients would be stored in a table of patient data. Similarly to the way that we have patient data, we would also be storing a table of doctor data. Each doctor has a doctor ID, the name of the doctor, the specialty of the doctor, which is going to be important. Patients want to see or be able to search for doctors with particular specialties, the license number of the doctor, perhaps their phone number, contact information, perhaps some other information about the doctor as well could be in this table. Now, third, we have the appointments data, which connects the doctors with the patients. Each appointment is an appointment of some particular patient with some particular doctor. The patient is referred to by their patient ID, which allows us to refer to a specific patient in the system. Note that even if two patients have the same name, we can distinguish between them because they will have different patient IDs. Similarly, we can distinguish between two different doctors with the same name or the same specialty even by their different doctor IDs. So a patient will have an appointment with a particular doctor. So patient number 4 has an appointment with doctor number 2 on the 12th of August of this year at 10:10 a.m. And there may be notes by the doctor that are filled out and entered into this table after the appointment that are stored for future appointments of the same patient with the same doctor or perhaps a different doctor. So this information here is now note one thing important here. The patient ID refers to a particular patient. So patient number 4 happens to be James Brown, and doctor number 2 is Michael Johnson, a cardiologist. But notice that there are multiple rows in the table that have the same doctor ID. So there are different patients that have appointments with the same doctor. In the same way, you might have one patient that has multiple appointments, either with the same doctor or different doctors at different dates and times. So the patient ID and doctor ID here do not have to be unique. They can appear multiple times in this table. Now, this gives us a structure by which to store the kind of data that we're looking for about patients, about doctors, and about appointments. What kinds of things can we do with this information? Do we want to do with this information? Well, for appointment scheduling and management, what are the kinds of things we need to do? Well, if you call up your physician's practice to make an appointment, probably one of the first things you're going to ask is, what appointments are available? So that you can find an appointment that fits your schedule. So finding out what appointments are available for a particular doctor or for a particular specialty is an important search function. We need to be able to schedule new appointments, which means adding new data into the appointments table at least. The doctors need to add or modify the notes for appointments. Patients might need to change appointments or cancel appointments, maybe some other things, but these are the basic functions. So let's have a look at how these functions might be implemented in a system. Let's talk about scheduling a new appointment. So let's suppose that John Doe wants to schedule a new appointment with Dr. Smith for April 1st, 2023 at 2 p.m. for a follow-up visit. So the first step that we would do is verify that Dr. Smith does not have an appointment at that particular time, which means look through the table of appointments for all of the appointments for Dr. Smith on April 1st at 2 p.m. If you find any such records, then this appointment cannot be made. If that appointment time is clear for Dr. Smith, then we're okay to go. Then, the second step, after we verify that Dr. Smith is available, we add a new record into the appointments table. So a new row is going to be added to the table with John Doe's patient ID, Dr. Smith's doctor ID, the date and the time, and any other relevant information such as the type of appointment, that it's a follow-up appointment, or other information such as the patient's complaint and so forth. We've added a new appointment. Now suppose that John Doe has made this appointment, but now needs to change the time to April 8th at 3 p.m. Now, let's assume that this time is already clear for Dr. Smith. We've already checked that. Well, what do we need to do? We need to find this record in the appointments table, the one that John Doe has an appointment with Dr. Smith at this date, at this time. No, we don't just look for a record that says John Doe has an appointment with Dr. Smith, because he might have multiple appointments with this doctor at different times for different purposes. So we have to look for the specific appointment that matches all of the relevant information. So we find just that unique record, and then we change the information in that same record to the new date and the new time. All of the information is there. We just need to change the relevant information, and everything else stays the same. There's no reason to change it. Finally, talking about appointments, we might want to cancel an appointment. Well, canceling an appointment is very simple. Find the relevant record in the appointments table. Again, searching for John Doe's patient ID, Dr. Smith's doctor ID, the date and the time of the appointment that you want to cancel, and then remove that row from the table. Remove that record from the database, and the appointment has been canceled. Searching appointments do finding all the records in the table that match a particular condition. So suppose that Dr. Smith wants to know, what is my schedule for March 1st? Well, she asks the database, and what the database will do is look through the entire appointments table, finding all of the records with Dr. Smith's doctor ID and the date of March 1st, 2023, ignoring the time and so forth. So a number of records will be found corresponding to every one of Dr. Smith's appointments for March 1st, 2023. Similarly, we could search for all of Dr. Smith's appointments, or we could search for all doctors' appointments on 2023 in exactly the same way. Whatever the conditions are, we set those conditions, find the records that match particular conditions. There are also a number of different kinds of record management that we would do only talking about patients or only talking about doctors. So if we want to talk about patient record management, suppose we want to add a new patient to the system. So a new patient comes in and says, I'd like to make an appointment with a doctor. Well, the first thing the database system needs to do is to add that patient to the patient record so that then that patient can make appointments and so forth. So to add a new patient, say Mary Johnson, born on February 2nd, 1985, female, living at 456 Oak Street, phone number such and such, an email address, etc., etc. We take that information and we add a new record to the patient table with all of this information, creating a new unique patient ID for that patient. So we know that this patient's patient ID will be unique. It's a different number than any other number in the table with all of her relevant information. Then the information is there. We can make appointments for her with her new patient ID. Suppose we need to update John Doe's phone number. So to update his phone number, we know how to update things. We just talked about it a minute ago. Find John Doe's patient record, search for his name, find the patient record. Once we found his unique patient record, then update the phone number from one number to the next. We just change that element of data within the record, and we're good to go. Now suppose we want to archive patients that haven't been in touch with a clinic for many years. So suppose that our criterion is a patient that we haven't seen for at least 2 years, we want to archive them. So there are a couple of ways that we might implement this. One is we might have an archived bit within the patient's table, which just tells us, is the patient archived or not? By default, patients are not archived. If we archive the patient, we set that bit to true. And then when we're searching for active patients, we only look for patients that are not archived. And then if we need to unarchive a patient, we just take that record and set the bit again to false, and now the patient will be active again. Another way to implement it would be maybe we have a separate table for information about inactive archived patients. So to archive a patient, we find their record in the patient table, delete the information from the patient table, and put that information into the archived patient table, moving the data from one table to another, and then we can look it up in the archive table. There are different ways to implement these kinds of functions depending on our representation of the data and what we want to do with it. And we'll talk about some of these issues when we talk later about database design. Now, the view that emerges from this way of thinking about data, thinking about what we want to do with our data, is that we have a number of different tables, each of which contains information about one thing that we're interested in. In the case of our example, we have patients, we have doctors, and we have appointments. We might imagine a more complex healthcare management system that also had tables describing different clinics and then tables describing which doctors work at which clinics on which days, and which specialties are served by which clinics, and many other different things. And these tables are then linked to each other by means of these unique IDs that patients and doctors and clinics and appointments and so forth may have, so we can link information about one kind of thing with information about other kinds of things. And thus, in the remainder of this course, we will be learning about comparatively simple, foundational, fundamental representation methods and operations for building databases. But keep in mind, how do these simple and primitive operations apply to each other recursively? We can build arbitrarily complex and very sophisticated database systems that enable the construction of the most powerful modern systems that span the globe, serve millions upon hundreds of millions of users in getting, retrieving, serving huge quantities of information on a split-second basis that power the global economy and affect our lives on a daily, even minute-to-minute basis.